Hello and welcome to this video on creating contour plots in Origin. Now to create contour plots, of course, the first thing that we need is data that needs to be plotted. And I have that data or that type of data over here. In this case, the data are calculated yields as a function of the flow rate of one reactant and the flow rate of another reactant in a chemical flow reactor. Now, the way that these data have been created, I have simulated them using a Python script. What I've done is I have made sure that I have the one axis and I have the other axis. Now, I'm always end up confused on whether the flow rate of chemical A or of chemical B, whether it's the columns or the rows in this particular spreadsheet. So what I've done on purpose to help me remember what is what is I've made this overview slightly asymmetric. So if we scroll down all the way to the bottom of this spreadsheet, or the numbers at least in this spreadsheet, you see that we are going up to a flow rate of 2.6, whereas the other flow rate on purpose goes up to only 2.5. So I've put that asymmetry into the data because I could and because it helps me to remember which axis is which. Okay, so let's go to actually creating the contour plot. Now in the contour plot, I want to, in this case, plot my yields as a function of, I might as well color these in, of the axes, and the axes are the first column and the first row. So my data is actually all these numbers over here. So if I select all of these numbers, one of the first things that I realize in the corner, in the bottom right hand corner, you can just see it over there, is that I have 104 rows and 100 columns. Now that is something that I am going to need to remember. So 104 by 100. So I'm now going to copy the data and I am going to go to Origin. Now in Origin, your standard workbook opens with a worksheet like this. But what we need to make this contour plot with this type of data, we actually need what is called a matrix. So I'm going to create a matrix. And the first thing that this asks me is how many columns do you have and how many rows do you have. So these are exactly the numbers that I said I needed to remember. So I'm going to say I have 100 columns and I have 104 rows. Now you can also see that my columns are X, that's the 100, and that was running, well, I might as well actually go back to Excel to show that. So my columns run up to 2.5 and they started at 0.025. So that's what I need to enter here, 0.025. And it goes up to 2.5. My rows, Y, also started at, and I'll just show that, 0.025. And they go all the way up to 2.6. 0.025 and 2.6. Now the long name, and this is because I know how these data were generated, this is the flow rate of B, and this is the flow rate of A, and the units are milliliters per second and milliliters per second here as well. Basically, if you have different data, you just write whatever your data are, the lowest value, the highest value, what it is, and what the units are. So now I have the right size of my matrix. I've defined my matrix and I'm going to press OK, and I see an empty matrix. And that is what I'm going to copy my data into. If it still remembers this, I may have to copy this again. Yeah, I copy it. Well, now I've copied it and it's been pasted in. And you can see in the corner over here, you can already see a little bit of a preview of what your data may look like. But actually, there is another thing that you can now do to make sure that you have created this matrix correctly. And you do that by going to View, and if you note Show X, Y, then your indices of your columns and of your rows become the calculated numerical values. So again, what we see now is that my rows go from 0.025 up to 2.6, and my columns go from 0.025 up to 2.5. So the fact that I see no surprises here tells me that I have transferred my data correctly from Excel into Origin. So the next thing that I want to do is I want to make my contour plot. So I go to Plot, I go to Contour, I do to Contour and Fill, and this is my my graph. Now, because this is a 100 by 104 matrix, it means that there are 10,000, a little bit more than 10,000 data points in this particular matrix. And as soon as Origin plots those kinds of graphs with a great many data points, it chooses to use something that is called speed mode, which is fine. It just means that while you are creating the graph, things will go a little bit more quickly. If you copy your graph into a PowerPoint file or into a Word document afterwards, it will then revert to the original resolution, but I'll also show how you can go to that original resolution anyway in the first place. So if I now make this graph full screen, what you see is that the axes have been labeled, glow rate, have been, I'll change that at some later time, have been labeled automatically. And this particular reaction has a maximum yield of 1, and the vertical scale, the scale that comes out of the screen towards you, the contours, go up to 1. So the scale is also being created automatically. So this is the graph that you want. I can also go to Graph, and let me just see Speed Mode. And if I open the dialog and I say that I want it off, then Speed Mode is now off, and you see that the graph is smoother. It would be a little bit harder to work with, but this looks a little bit nicer. If you look very carefully in the bottom corner over here, you can already see a little bit of the granularity of the data. Remember, well, we might as well do this over here. Both flow rates went up in steps of 0.025. That's how I generated the data. That's what my Python script was told to do. And you can kind of see that a little bit here already. But apart from that, this is the graph that you want. Now, you may, for lots of reasons, want to have a look at this graph on a logarithmic scale as well. So I'll quickly show how that works. If you double click on the axis and on the scale, you can simply change this to log 10. And I can do the same for the vertical axis. And if I now press apply, okay, this is what my graph looks like. So now, rather than showing the actual flow rates, it shows the orders of magnitudes of the flow rates. The other thing that you see in this case is that the artifacts of the size of the granularity of these data actually start to show up at the lower log scales, and that of course makes sense because this here, the distance between these points, are essentially the distance between my data points, and that just looks bigger on the log scale. Okay, so that's essentially how you can quickly turn data as a function of both an x and a y axis, and how you can turn that into into a contour plot that allows you to evaluate regions of X and Y, in our case ranges of flow rates where a chemical yield is highest. So thank you for watching, and I hope you found this video useful. See you in the next video. Bye.